Welcome back. Now let us start using the contours for the various applications, and one of those are the image matching. So what is the meaning of that? Let me explain in a very simple English. This is the image we are working with. Suppose we have to map this image, this particular piece of this one. Then we would like to know which one is like this. As a human being, if you see, we can see that this and this are similar, this is similar, okay, but even though these are the different orientation, because orientation does not matter. So when we are as a human being, we are going to match. Orientation does not matter. Probably size also does not matter. This is little bit thicker, this is thinner and longer, so this does not matter. Then now comes, divide this image in a two part. One, like from here, take a line here, take a line. Then the bottom part become a kind of rectangle, and upper part this become a simple tip of the arrow. Now rectangle part, if it is rectangle, then definitely this is rectangle. So there is definitely some percentage of match, not the 100%, probably say 70%. And if you see this rectangle part, here it is a 4 rectangles, so definitely there is some match. And if you see this is small part, this one and this part, all four are also matching. Now only the size, here it is bigger and here it is smaller. That is the difference. Okay, that is the difference. So this is the way, one of the way to match the images. So let me close this. And technically there have been the various way. We'll learn few things. One of those are the hue moments. So what is the hue moments? This is the one of the technique that compares the two contours based invariant to their rotation, scale. Rotation means it could be in any direction. Scale means bigger, smaller, does not matter at all. So we try to compare the two contours in such a way that whether they really match. So this is the one of the concept, and the detail is there in this Wikipedia over here. So let us see that how we are going to use the hue moments for comparing the two contours or image matching, whatever we can say. 102 we are taking from original to the temporary copy so that we can work with, and this is our test index. So that upper arrow which you saw in the image, so this is the text index. We'll try to match the upper arrow with others. So what it is doing, let me run it and then I will show you what it is doing. I'm running 103 to 112 in one go. Okay, so this has done something. Let me show you first that what it is doing. It has drawn a rectangle with red color. This is the red color, that is fine. And in the text, it has put that index, comma, score from the call called match shapes. Match shapes is one of the way to compare the two contours based on the hue moments. And it is taking that this is our test contours, this is test, and this is the current one in the for loop. Okay, remaining things you can look at the documentation. It is as documentation is very simple. So it is comparing the two contours, that's all. So let me run this again. 112 I'm running. So see, this itself is matching with this, that is 0. It means almost 100% match. And the bigger number, less amount of match. Okay, so if you see this part 1.95, 2.382, that is okay, decent. But one thing, if you observe, this is 0.25. It means this piece having good amount of matching with this compared to this 3 and 10, which is, as a human being, you may feel a bit surprising. Even with index 9, that is this rectangle, have the good amount of matching with this image. It is because this part, if you see this part, is similar to this part, bottom part. Okay, and another surprising is over here. Even if you see this eclipse, this is also matching. Okay, and this will not match. That is very much true. This is the high. Okay, this is high, and this will also not match. That is very much true. So now this is one of the way to match. And the lower the score or near to 0, then perfect. Okay. Now let us try to do a bit different. Now this is one of the way. Now let us try to do the matching in a bit different way, like count of vertices. What is meaning of that? That let us see is what if you have a rectangle and if you are trying to compare one rectangle with other rectangle, then the vertices count will be similar. Okay, because in case of rectangle there are 4 vertices, and so any kind of rectangle it is a 4 only. So any shape with 4 vertices will be more likely to match with each other. Okay. Now let us try to do with count of vertices. So here again similar simple thing. Let me run it, then I will show it to you. Okay, if you see the count of vertices, this is having count of vertices 7. That is the 1, 2, 3, 4, 5, 6 and 7. And which all are having 7? This is having 7, this is having 7. Luckily this is also having 7. Okay. Now we would like to know if you see this, all these 3, this piece and this piece, all these 3, index 3, 10 and 7, both all 3 are matching with each other. So it looks a bit better if you try to use the count of the vertices. This is a bit better, but definitely one error is also here, because even this piece is also having 7 vertices. Now what to do? Let me show you that how this piece of code has done. So this is the rectangle drawing across the image, and it is approximation. What is the meaning of approximation? Approximation that how many, when you try to draw the contours diagram in a polynomial way, how many points are there approximate. So this is what it gives, and we are printing the length of that. If you see, converting to length and then making to string. This is what it is all about. Okay. So this is the one of the way. It is so if you see that we are able to match it, and with only one exception. Okay. Now I want you to do the classwork that use both techniques, that using the score and count of vertices. See if you can come out with a way to a bit better matching where no exception is there, and just try to play with the different figures. This will be classwork, and please post your result in the discussion forum. I would like to see, and if you have any questions, you can write it there. That's all for this one. Thanks a lot for watching it. See you in the next one.